Hello, good morning. Today we are going to see software testing unit 2 session 5. In the previous topics we have studied positive testing and negative testing. In today's topic we are going to study another method of black box testing that is called boundary value analysis and equivalence partitioning. So these two techniques we need because due to time and budget considerations of the project, it is not possible to do exhaustive testing. Exhaustive testing means testing it in a very deep manner with taking all and each input, which is not possible. So we need an easy technique that can select less test cases and we can select these test cases intelligently so that maximum errors can be uncovered. So you have to select such test cases that maximum errors can be uncovered. So first let us understand. Following techniques are used for positive and negative validation of testing. So these two techniques, boundary value analysis and equivalence partitioning. So by these two techniques we will understand which is positive data and which is negative data. Further you will understand that how you will find out which is positive data and negative data using these techniques. So in equivalence partitioning, the input which you accept from the user is divided into partitions. It can be one partition, two partition, or many partitions. And that partition is called as equivalence classes. And this method is used to reduce the total number of test cases to a finite set of test cases. As I told you, due to the time and considerations, due to the time and budget considerations, it is not possible to do exhaustive testing. So this method is best to reduce the total number of test cases so that we can test more number of inputs. First, let us understand the definition. Equivalence partitioning is a software testing technique that divides the input or output data of a software unit into partitions from which test cases can be derived. As I told you, the input or the output data is divided into many partitions, and from those partitions you are going to derive the test cases. Test cases are designed to cover each partition at least once. So from each partition you need to select one test case so that from that partition you can test that each partition can be tested. Partitions with valid values are used for positive testing, while partitions with invalid values are used for negative testing. So the values which comes under valid data, like if we tell you to accept the values between 1 to 10, then 1 to 10 is a valid data and we consider it as positive values. And the values which are less than 1 and the values which are more than 10, we consider these values as invalid values and it comes under negative data. So from these partitions we'll understand which are valid data, positive data, and which are negative data. Take another example. Suppose if you are testing for an input box which is accepting 1 to 1000 numbers. So are you going to test for all 1 to 1000 numbers one by one? No, it is not possible. So to avoid this work or to avoid this lengthy manual work, what you are going to do, and there is also no use in writing all 1000 test cases for all 1000 valid input numbers. So if you use equivalence partitioning method, above 1000 test cases can be divided into 3 sets only. That is, one test case for valid partition and remaining 2 test cases for invalid partition. Let us see another example where they are given the field where the user is going to enter total how many number of pizzas he wants to order. So they are given some conditions. According to that, the pizza order will be accepted. So the pizza values 1 to 10 is considered values. If the user enters the value between 1 to 10 is considered as valid, and a success message is shown when the user clicks on submit. While if the user enters if the value greater than 10 like 11 or 99 are considered as invalid for order, and the error message will be shown like only 10 pizza can be ordered. So now you need to test this field. So how you are going to test this field? Are you going to test the this field taking each value from 1 to 10? Or are you going to test the values which are like 11, 12, 13, 14 till 99? Each value you are going to take and you test? No, this is not possible. So to test more number of values in a less test case, you can use equivalence partitioning method. See now, the condition is like, for equivalence partitioning method, the condition is like any number greater than 10 entered in the pizza order field, let's say 11, is considered invalid. That means the value greater than 10 is considered invalid. So this is first partition. Then any number less than 1 or 0 or below, it is considered as invalid. This is second partition. And the numbers between 1 to 10 are considered valid. And any 3 digit like say 100 is considered as invalid. So this is fourth partition. So based on these conditions, you need to recognize the partitions and you need to select each value from the partition and test this field. So let us see which are those partitions. See, first of all, recognize which is the valid partition. From 1 to 10, this is the valid partition. And less than 1, this is again invalid partition. Greater than 10, this is invalid partition. And even if there is any 3 digits, even this is invalid partition. So these are our partitions which we have recognized from those conditions and from the field. So as we have discussed, we cannot test all possible values because if we do, the number of test cases will be more than 100, which is not possible. To address this problem, we need to use equivalence partition technique, where we divide possible values of inputs into groups. Then what we do? Then we need to pick only one value from each partition for testing. So if one condition or value in a partition passes, all others will also pass. And if one condition in a partition fails, then all other conditions in that partition will fail. So see this example. So we have selected here, suppose if the user enters -1, then it comes under invalid partition. So it comes under this partition. And if the user enters value 5, it comes under valid partition. And if the user enters 88, it comes under invalid partition. And if the user enters 121, it comes under this partition invalid. So from each partition, you need to select only 1 values. You need to select only 1 values so that we'll understand that this partition works successfully. So if this partition works for 1 value, then it works successfully. So no need to select all the values. Only 1 value is enough. Take another example. They are given a text field which accepts only numeric values and it accepts only 6 to 10 characters. So what can be the partition for this? First recognize valid partition which is between 6 to 10. Then recognize invalid partitions which is less than 6 and greater than 10. So you are not going to select all these values. You can select any 1 value from this partition then it will work for that whole partition. So from this valid partition also only one value you are going to select and you are going to test it. Even from this partition only one value you are going to select and you are going to test, so that it works successfully for that whole partitions. So we need to understand from this equivalence partitioning method that it will reduce the number of test cases. So from each partition select one value. So if that one value works successfully, then you need to understand that it will work successfully for all other values. And if it fails, then you need to understand that it is also not going to work for all other values. So in today's topic, we have studied equivalence partitioning. In the next topic, we will study boundary value analysis and examples on both equivalence partitioning and boundary value analysis. Thank you.